They fly low, strike fast, and disappear before you even know they were there. The Apache helicopter isn't just a machine, it's a battlefield predator, engineered from the ground up for modern war. But how exactly is this high-tech warbird built, assembled, and armed? From raw titanium panels to complex rotor systems, and from helmet-linked targeting to fire-and-forget missiles, every part of the Apache is purpose-built for destruction and survival. In this video, we'll take you deep inside its creation, step by step, to uncover what makes the Apache the most feared attack helicopter in the world. Origins and development of the Apache helicopter. The story of the Apache helicopter begins in the thick of the Cold War. In the 1970s, the U.S. Army knew it needed something new, a helicopter that could fly low, hit hard, and survive serious firepower. That's when Hughes helicopters entered the scene with a design that would eventually become the AH-64 Apache. There was a fierce competition. The Apache wasn't the only candidate. It had to beat out the Bell 63, which was sleeker but less durable. In brutal field trials, the Apache proved it could take a beating and still keep flying. It was tougher, more stable, and packed a deadlier punch. That made the difference. Later, Hughes was bought by McDonnell Douglas, which eventually merged with Boeing. And that's how Boeing Defense became the main builder of this beast. The first Apaches rolled out in the mid-1980s, and by 1986, they were in full service. Right from the start, they were different. Unlike older helicopters, Apaches were made to go straight into high-risk zones, right alongside the front lines. They weren't built to just hover and scout. These were designed to hunt tanks, support ground troops, and survive under fire. Every line of the Apache's frame, every system inside, was tailored for real combat, not just theory on paper. What really made the Apache stand out was its battlefield performance. In conflicts like Desert Storm, the Apache didn't just survive, it dominated. Crews reported incredible accuracy, and ground troops relied on it like clockwork. It had earned a nickname, the Tank Killer. Today, even after decades of upgrades and tech overhauls, the Apache still starts with that original mission: survive, strike, and return home. And it's this purpose that continues to shape how every single one is made. Airframe construction and fuselage assembly. Now, let's walk through what the Apache is physically made of, and why. The body of the Apache isn't just slapped together with sheet metal. Every part of its airframe is a calculated decision between weight, durability, and battlefield survival. The frame starts with a mix of aluminum and titanium, combined with composite materials. These composites are key. They help reduce overall weight while adding resistance to bullets and impact. Boeing builds the airframe in major sections: the nose, center fuselage, and tail boom. Each part is machined separately using high-precision tools and then welded and bolted together like a massive military-grade puzzle. But what's really interesting is how it's built to survive. The Apache isn't just armored it's engineered with redundancy in mind. That means if one system fails or takes damage, another can take over. This includes dual hydraulic systems, shielded electronics, and reinforced landing gear. The fuselage is also capable of absorbing damage from 23mm high-explosive rounds, a common battlefield threat. The canopy, where the crew sits, is made of bullet-resistant glass. It's thick enough to handle direct hits from a small arms fire and still give the crew full visibility, which is crucial in fast, unpredictable combat environments. Throughout the fuselage, you'll find removable panels and access points. This isn't just for ease of maintenance. It's also a nod to how often these helicopters need to be serviced between missions. Boeing builds with future upgrades in mind, making it easier to slot in new tech without a full redesign. So when you see an Apache on the flight line, you're not just looking at a machine, you're looking at a battle-hardened structure, one that's built layer by layer to fly into danger and come back out in one piece. Dual cockpit and crew integration. Step inside the Apache and you'll find a two-seat cockpit that feels more like a sci-fi fighter jet than a traditional helicopter. But there's a reason for that layout: function over form. The gunner sits up front with a direct view of the battlefield. Every control related to targeting, weapons, and camera systems is within arm's reach. Behind them, slightly raised, is the pilot's seat. From here, the pilot manages flight controls, navigation, and tactical coordination. The higher seating position gives better visibility, which is critical when flying just feet above tree lines. Unlike some helicopters where only the front seat does the real work, both the Apache's pilot and gunner are fully equipped to fly and fight. They each have their own screens, flight sticks, and control interfaces, and they can switch roles if needed. This kind of redundancy gives the crew more flexibility in combat. Inside the cockpit, every inch is optimized. Helmet-mounted displays project target info right onto a glass lens in front of the crew's eyes. That means they can see key data without looking down. And those helmets aren't just passive, they're tied to the camera systems. Turn your head, shown, and the sensor turret turns with you. Communication between crew members is seamless thanks to an integrated comms system. Whether flying in formation or coordinating an attack run, they stay in constant contact even when things get loud. And most importantly, the cockpit is armored and crash-resistant. In the worst-case scenarios, it's designed to protect the crew long enough to escape or get picked up. Every button, every display, and every switch inside is placed for speed, survival, and split-second decisions. Because in the Apache, every second counts. Avionics, optics, and targeting systems. What gives the Apache its bite isn't just brute force. It's what it can see and how fast it can lock onto threats. Let's look at the real game changer, the optics and avionics suite. Mounted under the nose is a rotating system called TADS, PNVS, short for Target Acquisition Designation Sight and Pilot Night Vision Sensor. It's like the eyes of the Apache. The gunner uses TADS to find targets, day or night, rain or shine, thanks to infrared cameras and high-zoom optics. Meanwhile, the PNVS is hooked up to the pilot's helmet, moving as they move. This makes flying in pitch-dark or dusty combat zones not just possible, but precise. Then there's the longbow radar system, that iconic mushroom-shaped dome on top of the rotor. Don't let the shape fool you. Inside is a 360-degree millimeter wave radar that can detect and track up to 300 targets at once. It prioritizes the threats and even shares data with other aircraft in the network. What's wild is how all of this connects. The targeting system doesn't need the helicopter to point directly at an enemy. With helmet aiming, the gunner can look left, and the 30mm chain gun follows their line of sight. If they see it, they can hit it. The whole system is wired into a central computer that not only manages fire control, but also helps the pilot keep situational awareness in high-stress combat. That means faster target acquisition, less exposure, and more accurate shots, all without breaking formation or hovering in the open. So when people say the Apache is smart, they're not kidding. It's not just a flying tank, it's a flying data center with a trigger finger, weapon systems, and combat loadouts. Now let's talk about what makes the Apache such a nightmare for anything in its sights: the weapons. Its main gun is the M230 chain gun, a 30mm cannon mounted right under the cockpit. It fires up to 600 rounds per minute and is controlled directly by the crew's helmet movement. That means the gun fires where they look, fast, accurate, and brutal against light armor and enemy positions. But that's just the beginning. Each Apache has stub wings on either side, and each wing has 2 hard points for weapons. That's a total of 4 pylons, and what they carry depends on the mission. The standard loadout? 16 Hellfire missiles, laser or radar-guided, fire and forget, and capable of destroying tanks in seconds. If the mission calls for suppression, the pylons can be fitted with Hydra 70 unguided rockets, perfect for soft targets, structures, or flushing enemies out of cover. There's even the option to mount Stinger missiles for air-to-air defense or Sidewinders to handle aerial threats. What's brilliant is how the Apache can mix and match. 2 pylons could carry Hellfires, and the other 2 could load rockets, giving it flexibility on the fly. And because the weapons are integrated into the fire control system, both the pilot and gunner can engage targets at the same time, switching between weapons in seconds. In a matter of minutes, an Apache can clear enemy armor, suppress ground troops, and still have the firepower left to defend itself, all while moving at over 150 mph. barely above the tree line. Engines and power transmission. What keeps the Apache airborne isn't just its aerodynamic shape, it's raw power delivered through two General Electric T700 turboshaft engines. These engines are built to do one thing exceptionally well: deliver reliable thrust in the harshest environments. Whether it's the dust of Iraq or the freezing altitude of Afghanistan, these engines don't flinch. Each one cranks out around 2,000 shaft horsepower, and together they send power straight into the heart of the Apache's drivetrain. The process begins with air being pulled in through the intakes. That air gets compressed, mixed with fuel, and ignited. The resulting blast spins a turbine, which in turn drives a central shaft. That shaft connects to the transmission system, and from there, power flows to the main rotor and tail rotor. It sounds simple, but the engineering is anything but. Every single part of this setup is fine-tuned to respond instantly to the pilot's inputs. But what happens if one engine fails mid-mission? The Apache can keep flying. Its redundant powertrain means the second engine can take over in emergencies, buying precious time for the crew to return safely. On top of that, exhaust suppressors reduce the heat signature, making it harder for enemy missiles to lock on. Every bit of that engine power is carefully channeled, not wasted. Cooling systems prevent overheating in desert combat. Filtration systems protect the engine from sand and debris, and advanced transmission gears make sure all that torque is distributed efficiently to the rotors. It's not just brute force. It's controlled, intelligent energy that lets the Apache hover, climb, dive, and swerve at will. So the next time you see an Apache scream overhead, remember, it's not just flying. It's orchestrating a symphony of spinning parts, each one calibrated for speed, survival, and relentless performance. Rotor mechanics and aerodynamics. Once that engine power is delivered, the real work begins. And it's all thanks to the Apache's incredible rotor system. At the core of its flight are the main rotor blades, 4 of them, made from advanced composites that are both lightweight and battle-hardened. These blades are constantly changing pitch, meaning they tilt ever so slightly, to control how much lift is being generated. Now, the way they do this is through something called a swash plate mechanism, a rotating disc that shifts with the pilot's inputs. Want to go forward? The swash plate tilts forward, changing the blade pitch in just the right way. Want to bank left or right? The same system does the trick, all without the pilot needing to think about the physics behind it. It's one of those behind-the-scenes pieces of engineering that makes helicopter flight feel effortless, even though it's anything but. Then there's the tail rotor, located on the end of the long tail boom. The main rotor blades spin in one direction, which would normally cause the entire body of the helicopter to spin the other way, like trying to stand on a spinning platform. The tail rotor fixes that. It pushes against the torque, stabilizing the craft and allowing for controlled yaw, or turning left and right. Even that tail rotor adjusts its pitch dynamically based on how much torque the main rotor is generating. The whole system is built for combat. The blades are reinforced to take hits and keep spinning. Even in turbulent air or sudden weather changes, the Apache stays stable. And most impressively, the rotors are designed to be relatively quiet at a distance, giving the helicopter a critical edge when stealth is the difference between striking first or getting spotted. So behind every smooth motion of the Apache, every climb, hover, or quick dodge, is a precise dance of rotors and gears, quietly performing the miracles that keep it flying under fire. Pilot controls and flight handling. From the outside, it might look like the Apache is being wrestled through the sky, but inside the cockpit, the controls are so refined that flying it feels more like guiding a thought. The pilot uses 3 main tools: the collective, the cyclic, and the tail rotor pedals. Each one works in perfect sync to let the helicopter move exactly where it needs to: up, down, sideways, or even in reverse. The collective lever changes the angle of all main rotor blades at once. Pull up, and the helicopter lifts off the ground. Push down, and it descends. Simple in concept, but this single control determines whether the Apache climbs over a ridge or ducks under enemy radar. Then comes the cyclic stick, which moves the helicopter forward, backward, or sideways by tilting the rotor disc. It's the control that gives the Apache its famous agility. allowing it to bank around buildings, drift sideways into cover, or circle a target like a hawk. Meanwhile, the tail rotor pedals control rotation, basically turning the nose left or right. These let the pilot align the Apache to targets or steer through tight spots. Together, these controls form a natural triangle of motion, giving the crew precise handling at all speeds and altitudes. But the real magic is in how effortless it all feels. The controls are fly-by-wire, meaning digital signals replace heavy mechanical linkages, making movements smoother and faster. Stability systems constantly make micro-adjustments, keeping the helicopter steady even during sudden maneuvers or gusty wind. And here's where things really get cool. The pilot and gunner both use HOTAS setups, hands on throttle and stick. That means they can fly, aim, and fire without taking their hands off the controls. It's designed so that in the heat of combat, there's no fumbling, just focus. Result? A machine that doesn't just respond, it anticipates. In the Apache, flying becomes second nature, so the crew can concentrate on what matters most, completing the mission and making it back alive. Tactics, strategy, and battlefield role. The Apache isn't just a flying weapons platform, it's a tactical asset engineered for the modern battlefield. Its combat strategy is built around one core idea: hit hard, vanish fast. That means flying low, using the terrain to stay hidden, and only popping up to strike when absolutely necessary. This tactic is called masking, and it's what allows the Apache to survive in places where other aircraft wouldn't stand a chance. Using the longbow radar, the Apache can scan an entire battlefield from behind a hill or forest line. It can identify hundreds of potential targets without ever being seen. Once the data is gathered, it prioritizes threats, locks on, and sends the info directly to its Hellfire missiles. Then, in just seconds, it rises up, fires, and drops back into cover. Fire and forget. It's that fast. But the Apache doesn't always work alone. It often operates in hunter-killer teams, where one helicopter spots the targets and another moves in for the strike. Sometimes it works with drones or forward ground units to paint targets, giving commanders a complete view of the battle. In convoy escort roles, it flies ahead, checking for ambushes. In Overwatch, it lingers at a distance, ready to react. Its flexibility is unmatched. One mission might call for anti-armor strikes, the next for suppressing infantry or defending troops on the move. Thanks to its powerful sensors and quick-react weapon systems, the Apache can shift between these roles in real time, without needing to refuel or rearm mid-battle. And it's not just reactive, it's proactive. The Apache is used to shape the battlefield, to deny space, slow enemy advances, and give allied forces room to breathe. It's a frontline tool with deep impact, not just another aircraft flying overhead. In short, it's not just about the weapons or the armor. It's about how it all comes together. The Apache doesn't just fight, it thinks, adapts, and leads from the skies. Size comparisons in modern use. When you stand next to an Apache, the first thing you notice is its sheer presence. This is not a small machine. From nose to tail, it stretches about 48 feet, and the rotor blades span the same distance across. It stands over 15 feet tall, roughly the size of a two-story building. Up close, it's less of a helicopter and more like a mechanical beast built for war. But how does it compare to others? The Russian Ka-52 may have a taller profile with its twin rotors, and the Super Cobra is leaner and faster in some roles. But the Apache brings something unique to the table: durability, sensor integration, and fire control precision. Its ability to track, prioritize, and engage targets without exposing itself makes it one of the most lethal aircraft in its class. Modern versions like the AH-64E Guardian have pushed that even further. These come with digital comms systems, better engines, and the ability to control drones directly from the cockpit. That means one Apache can now coordinate an entire aerial team, feeding real-time intel to command centers while simultaneously engaging the enemy. Apaches are now flown by over a dozen countries, including the UK, India, Israel, and Saudi Arabia, each customizing the platform to suit their needs. Whether it's jungle warfare, desert patrols, or mountain operations, this helicopter adapts. And the upgrades haven't stopped. Engineers are already working on future versions with AI-assisted targeting, reduced radar signatures, and increased autonomy. The goal is to make the Apache even more survivable in next-gen warfare, where threats evolve by the day. So while the Apache was born in the Cold War, it's far from outdated. It's a constantly evolving symbol of precision, power, and presence. One that's just as relevant today as it was decades ago. In a world full of high-tech drones and jet fighters, the Apache still carves out its place, low, fast, and lethal. From the factory floor to the front lines, the Apache helicopter is a masterpiece of modern engineering. Every detail serves a deadly purpose. If you enjoyed this deep dive into how it's made, make sure to subscribe for more breakdowns like this, and let us know what you'd like us to cover next.